S. Chan presents educational video lectures. Difficult concepts made easy. Study anywhere, anytime.
Hello students, as we have learned in the previous videos about the wave equation.
If you want to study this topic in detail, refer to the book by S. John Publishing. Link is provided in the description box.
Welcome to the S. Chan Academy and my name is Kanhaiya Jha. In this video I will be teaching you one-dimensional wave equation, that how to make the calculation related to the motion of the particular wave, tension produced in the particular string, displacement and all. So basically the entire concept is that the waves propagate, and why it propagates? Because the restoring force is acting. If you see here, then what we can see is that this is the wave, and we can see that continuously it is coming to the mean point and continuously it is going away from the mean point. It is coming to the mean point and it is going away from the mean point because the restoring force is acting on the particular wave. So we can say that F is equal to minus of kx. This is the first thing that we have to understand. So the restoring force acting. So in this particular video we will learn that how the motion motion of the particular wave. The motion of the particular wave can be studied in terms of the one dimension, can be studied in terms of two dimension. We can calculate the tension produced in the particular wave. That motion takes place on the xy axis. Then there is a string in perfectly flexible, the restoring force acting on the string, then tension produced in the string and the displacement acting on the string. So we can say that clearly that this is the particular wave, and from this particular wave what we have to calculate d2y by dt square equals c square d square y by dx square. Let's learn it more and let's take some more examples for this. That suppose we are taking again the example here that y is equal to a cos omega t plus phi. Y is equal to a cos omega t plus phi. Then what we have to understand here, that we can this is a displacement equation. From the displacement equation we can calculate the equation of the velocity, and then we can calculate the equation of the acceleration. So when we calculate the equation of the acceleration, that particular equation will be nothing but d2y by dt, if we are taking y as displacement. So here we can see that this is what we have to do. d2y by dt square is equal to c square d square y by dt square, dx square. So what we are doing is we are calculating the wave in terms of the xy axis. We are calculating how the motion of the particular wave will vary in terms of x and y axis. Then we will calculate that how the particular string will act, then how the tension will be produced in the string, and then we calculate the restoring force which is acting on the string. We have to calculate after the restoring force how we are calculating the propagation of the particular wave, and then the tension produced in the spring. So we have to calculate this calculation in this one-dimensional wave equation. So here we start the calculation. The calculation is basically d2y by dx square. Now there T1 and T2 are the two particular the values. Okay, when we are taking the mass of the spring is m, and the mass per unit spring is given up to us, considering the motions pq and qs. So we are taking the assumption this is the bending tension T1 and then tension T2. So when the wave is propagating, when the force is acting on the particular wave, then we are taking the value of the tension as T1 and T2 when the wave propagates. T1 and T2 are the two particular value of the tension. Now T1 cos alpha is equal to T2 cos beta, and the T is a constant. So when we modify this equation, how we can modify this equation? by using the Newton's second law of motion, where we say that the external force is equal to the rate of change of momentum per unit time. So we can say that F delta S d2y by dx square is equal to T2 sin beta minus T1 sin alpha. So M delta S is equal to d2y by dx square T cos alpha sin beta minus T cos alpha sin alpha, and then we'll reduce this equation d2y by dt square M delta x tan beta minus tan alpha. So again d2y by dt square will form this equation, and in the last we will get a wave equation which is d2y by dt square is equal to c square d2y by dx square, and c square is equal to t by m. It is basically that when the wave is propagating, and when the wave is propagating, there is a displacement equation given to us. Okay, here again we see this is the wave. X is given in terms of displacement equation, and then we calculate dx by dt, and then we calculate d2x by dt square. So here in a very simple analysis, this can be also the analysis of the wave equation, where we can say that d2x by dt square is equal to minus of omega square x. If we take any particular wave equation which has a periodic motion or a periodic vibration, or which is under the following the simple harmonic motion, so we can see that d2x by dt square is equal to minus omega square x, and then d2x by dt square plus omega square x is equal to 0. Here what it includes, that basically that we are following the Newton's second law of motion. According to Newton's second law of motion, it says that F is equal to ma, in a very basic thing, or F is equal to ma, or we can say that F is equal to m dp by dt. So it will be m dp by dt. So F is equal to ma in this case. So external force acting on the body is equal to the rate of change of momentum. So here also what we are concluding is that when the displacement equation is given to us, from the displacement equation we will be calculating the acceleration, and then we come to the conclusion here. This is the acceleration, and from this particular acceleration the conclusion will be d2x by dt square is equal to minus of omega square x, or d2x by dt square plus omega square x is equal to 0. In a very summing word, very easy word, what we can say that this is a differential equation of the wave. So here also we have done the same thing. If you see the slides, we calculate d2y by dt square, and after calculating dy by dt square, we conclude here that d2y by dt square is equal to c square d2y by dx square, and c square is equal to t by m. So what we have taken into account, that how the particular tension is acting on the spring, and from there T1 and T2 are the two particular values of the particular tension produced in the string, and then we are calculating the variation in the particular string, that how the variation is generally acting on the particular string. We are calculating the initial value y is equal to fx when t is equal to 0, and dy by dt is equal to 0 when t is equal to 0. These are the conditions that we have calculated. Then we are calculating the solution of the one dimensional wave equation. d2y by dt square is equal to c square d2y by dx square. So in the same way we have discussed that when we calculating the particular acceleration, d2y by what we say dx square is equal to c square d2y by dx square, and then c square is equal to t by m, where t is the tension produced and m is the mass. So yxt is equal to fx zt. This is also a solution where we say that d2y by dt square is equal to fg, and d2y by dx square is equal to fng. So fg is equal to c square fg. When we divide both the equation, we will get this equation, this particular equation. So this is the equation in the one particular dimension, where g by c square g is equal to f dash by f, and that is equal to k. So this is the wave equation in terms of the one dimension, that how it is propagating, how we are calculating the difference in the particular one dimension of the wave, okay, and then with the different values. So here we can see that f double dash k minus kf is equal to 0 and g minus kc square g is equal to 0. So we satisfy the boundary condition here that u0t is equal to f0 into zt0 and u1t is equal to fl gt is equal to 0. So we'll get this particular equation f0 is equal to 0 and fl is equal to 0. So there are few conditions where we take the value of k to be 0. We'll take the value of k to be positive when it is greater than 0, and we will take the value of k which is less than 0. We will take the three particular cases and then we will calculate it. So in general, fx is equal to a cos px plus b sin px. So what we have discussed here, that y is equal to a, I give you a different example here, a sin t plus b cos omega t. We can take like this also. So different variables are taken. This is p, x, and this is a, and this is b. So we can see the changes: a cos px plus b sin px. Applying this f0, it will be 0, a0 plus b1, a is equal to 0. So here also we can see that how the wave is propagating, and from this particular propagation we are calculating the changes. We are calculating the initial position, we are calculating the particular changes in the initial position with respect to the displacement, with respect to the acceleration produced. After calculating the acceleration produced, we are calculating the Newton's, relating this with the Newton's second law of motion, where we are saying that the change in the rate of momentum, and then we are calculating the tension in the particular string and all. So what we have learned till yet is the propagation of the particular wave in one dimension, where we are taking the displacement equation of the particular wave, and after taking the displacement equation of the particular wave, we are analyzing this with the Newton's second law of motion and we are calculating it. We are putting the initial value to be 0, we are putting the initial value to be more than 0 and less than 0, then we are calculating the changes in the particular wave equation. So we will learn further after the break.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on AICTE curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting at your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Welcome back, students. So before the break, we have learned about the wave equation in the one dimension. We have calculated the different calculations, and we have concluded that how d2x by dt square is equal to minus of omega square x, or d2x by dt square plus omega square x is equal to 0. Now we'll continue further, and we have done the one wave equation. So here we can see that yn xt is equal to fn x the gnt. So yn xt is an cos n pi c by 1 t plus bn sin n pi c by 1 by t. So here, by using the principle of superposition principle says that the totality of the particular wave, if we look here, the totality, suppose that the wave is propagating like this, the wave is propagating like this, then what we say is that the total propagation, suppose this is y1, y2, so yn, this one is yn, so the yn is y1 plus y2. So we can say that a total yn, summation of yn here, yn is summation of yi from yi is equal to 1 to I is equal to n. So we have all the values that if the variation is calculated from y is equal to 1 to y is equal to n when we are calculating with the yi, so when the different waves are propagating. So this is the superposition principle. So here we can use the same superposition principle here. We are calculating for an cos n pi c by lt, and similarly we are calculating for the bn. So applying this formula now for fx, we will get the equation for an, and we can calculate the value of the x. So here we can see that how we have calculated the value for the an and the bn, and then we have used the superposition principle. after using the particular superposition principle, then how we have made the particular calculation. After making using the superposition principle, we have concluded the particular value of y xt, which is the summation of the n pi c by 1 t and sine n pi x by l. So this is what we have done in this particular equation. We will proceed further, and we will here understand what are the steady state condition. Steady state condition and how we calculate the variation in the steady state condition. So the steady state condition is dE by dt is equal to dEg by dt. So basically when they will cancel out each other. Steady state is basically when we are calculating the rate by which the energy is generated plus the energy is used or energy is transferred. So if we focus ourselves for the conservation, it has to be 0, as we see that when the energy is generated and the energy is released, it means that the entire energy is generally converted from particular one form to another. So dE by dt is the rate of change of energy or the heat diffusion. So here we say that E is equal to mCp T PV Cp T. So this is the input equation where we calculate the Qx, and this is the output equation where we can see that Qx plus dx. So when we say Qx plus dx, it means that Qx plus dqx, which is equal to Qx plus d2x by dx into dx. So here we can see that rate of change of doing work, or the conservation of the energy or the conservation of the particular input. Steady state analysis, what we concerned with that, how the input is generally given and how the input is generally utilized. So when the input is generally given, so in that particular case the input has to be transformed into the other type of energy. So here in the steady state we will study that how the input is generally analyzed in terms of the other form of energy, and after that what happens, that transformation of energy will happen. Transformation of energy from one particular type to the another particular type will happen in this particular equation. So here again we can see the heat diffusion equation where we see that dE by dt and dEg by dt, and this is input minus output. So this is what we are taking, but in the general form we can write the equation here: d by dy k dt by dy plus d by dj k dUd by dj. So this is the partial differential operator where we are using the operator t x y g t. What we are doing is we are formulating the particular input to get a particular output. We are using the input in a different form here, and every time our concern is that for a given particular input, what will be the output, that from a given particular input are we able to calculate a conservation, and if we are able to calculate a conservation, then after the conservation do we get the entire thing to be 0. So these are the calculations that we can do here. Now we can see here that heat diffusion equation we have done little bit, but again here we can see that delta square T is equal to d square T by dx square dy square ds square is equal to 0. This is a Laplace equation that we form. Here also we can see 0. That the totality is coming to be 0. It means that whatever is the input we are giving to the particular wave equation, or whatever the input energy that we are giving, from that particular input energy we are able to calculate the output. The input is converted into output. This is the 0 that we are getting. So here again we see that the heat diffusion equation, that is dt by delta T by dt is equal to Q. Then we are taking in terms of Q, the T and all. So we can see here that here in this particular case the rate of change will be 0 when d by dt is equal to 0 and Q is equal to 0. So it is forming the particular equation delta square T is to the entire summation to be 0. So in this particular case what we conclude is that when we give the particular input and we analyze the particular input, the input is generally transformed into the other type of energy, and when the input is transformed into the other type of energy, then the output that we are getting, that will be equal to 0. Steady state condition for the one dimensional, as we have discussed earlier also, steady state condition. So basically steady state condition, again we can see here d2t by dx square is equal to 0 for particular these variables. So we can see that here we have calculated dt by dx for a constant c1, and we can calculate it for c1x plus c2. c1x plus c2, when we are calculating, then c1 and c2 are basically the two constant which are used to calculate two particular boundary values. Some examples are given that T1x is equal to 0, 100 degrees Celsius is C2. So Cx is equal to 1, then 20 degrees Celsius. So C1 plus C2, and C1 we have calculated Tx value. So here again the heat transfer equation, and the heat transfer equation again we are calculating it from the input to the particular output, that what exactly the input of the particular equation and the output. Q is equal to minus of K dt by dx. Okay, this is a temperature gradient where we are taking the Q as a constant, and then we are calculating the dt by dx. dt by dx is basically, as we can see, the change in the temperature. And when we calculate change in the temperature, then we get the particular value of the particular circuit. Then we have the thermal resistance. Thermal resistance or the wall heat transfer. Thermal resistance is basically the conversion of the temperature when we keep the two bodies in contact. So we can see here how the temperature is converting here in the Q, T1 minus T2 by R, and T1 minus T2 R1 plus R2, when the value of R1 and R2 is given to you, and we conclude here for T1 minus T by R1. Then it is a wall heat transfer. We can calculate the wall heat transfer as T2 minus T1 for the particular value of R, and for a particular value of R we can make the calculation. So here R is equal to delta T by Q double dash, or delta T by K delta T by delta X. So delta X by K is what we have to calculate. So we have taken a small example here that R equal to delta X by K. So we have keep the value when the question is given the typical space inside the residual frame wall is 3.5 meter. Okay, find the value of R. So we are calculating the value of R in this case. So what we conclude here, that in this particular video we learned the one dimensional wave equation. We learned that how the propagation will happen, how we learn that how the Laplace equation, the entire thing d2y by dx square plus dy square plus dz square coming to be 0. The input that we give to the particular machine, how the output is 0, it means the total transformation generally takes place. Then we have discussed the particular value of R also, and this particular video enables you to make the calculation related to the one dimensional wave equation.
If you want to study this topic in detail, refer to the book by S. John Publishing. Link is provided in the description box. If you found our video interesting, please like, share and subscribe. And do not forget to press the bell icon.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.